either. So I just met.
Is Spencer wherever that picture is from?
No, I don't.
He's not there right now. He better
It looks very nice.
In his mind, he is.
Because that would be nice.
Hey, Brian, this is going to be kind of noisy. Could you do me a favor? So originally we were going to have sort of a more nuts and bolts talk today in terms of technology, but we had a few people that were kind of busy. So I said, I kind of didn't say, okay, I'll do something, and then I said, all right, I'll try to do something, and then Spencer actually came up with something, but it's about 25 minutes long, and by the time I got it, I'd done a lot of stuff, so we're going to jointly talk today. We're going to start with him, and then we'll go into some of what I have. I'll try to stop if it looks like we're ending up with too much. Okay, I like doing the Minority Report thing here. So if we end up with too much, I'll stop early, and then we'll just finish the rest the last week, and then we'll have the last week we'll do a discussion for basically sum up of and I'll do a sum up of the semester, where we go from now discussion, and next week is L3. So we have the CHI, whatever they call it there, person for L3. So that'll be fun. Okay, so we'll start with Spencer.
Hello all.
Hi Spencer.
Sorry I couldn't be with you today. At least in person. As I chatted with Dave about what we could do for this week, one of the things that I've been interested in, like I wanted to talk about, is the future of the user experience. And it's not that I'm an expert in it. This presentation is not going to be anywhere near as good as the presentations that have been done. But rather the idea is that maybe it will provide a jumping off point for some discussion as to what's coming in terms of interface. We've really seen kind of a shift in paradigm from just a few years back when everything was a keyboard and mouse. Now we're seeing a lot more of this, right? A lot of the thumbs on the device. We get the thumbs going, right?
Okay, so what he starts to talk about is this idea of these different interfaces that are, in many ways, a whole body experience or using different senses. And he gives us a whole bunch of different examples. The first one, let me just go to, is this one.
Jellyfish.
Let's see. Google's obviously a verb here. It's beautiful.
All right. Well, thankfully, by the way, I'm not part of Google Glass, even though I was down there in that little corner. But you've heard, I'm sure most of you have heard of Google Glass coming out recently, and its interface is a pair of glasses, right? That makes it complicated when we talk about design of where to put stuff and how we're going to interface with that. And in this case, it was a lot through voice, right? Well, we've seen other things too. If we pull up, let me pull up another video here. Take a look at this.
How many buildings are there?
Am I to include the Belgian waffle stand?
That was rhetorical, just show me.
Okay, so basically you can see that this idea of holographic image and manipulating it with the hands and voice. So a a lot of multimodal, plus the computer has sort of a Siri surly attitude during the interaction as well. Just show you something that we look at next.
All right, well, you get the idea. We've seen this kind of technology in terms of, you remember watching Minority Report, and now Tom Cruise was interfacing with the computer there, and we're seeing more and more of them. And the technology is there. In fact, I'll just pull up another little video here from the Kinect, this is even a couple of years ago.
Let's hit the track in the hottest new car of the year, the 2010 Ferrari 458 Italia. With Kinect for the Xbox 360, you can drive this car simply by putting your hands at 10 and 2. You can move your head around the interior, or even look into the corners. As you'd expect, this experience is running in beautiful HD at a seamless 60 frames per second. Now in this mode, points are scored for passing a continuous stream of less powerful cars. But the racing can get pretty intense all the same. Nice, that was really good.
Okay. So you can see the guy that was kind of standing off to the side, and he's doing this as we're driving, and it's, the Kinect box is figuring it out. So again, obviously, hand motion being effective. One of the things that we sort of notice is some of how science fiction kind of things in movies, for example, end up finding their ways into real life, and vice versa.
And so it's a whole different ball game when we're looking at it from that perspective of how we're going to interface with these devices. You may have heard recently that Apple and Samsung are now in a battle for creating a smart watch. So instead of smartphone, we'll have a smart watch. And I happen to have an exclusive inside picture of that I thought I'd show you. Here it is. There it is. Anyway, hopefully it'll be a little more attractive than that and a little more convenient. But that's the idea. We're getting to a point where if we could have a better way to interface with the computer, then we could get computers that are wearable, whether they're glasses or a watch or some form of clothing, that can still accomplish the same task, but we have to have a way to interface with those computers. And I found this other little demo that I thought was pretty cool from a company called Oblong Industries, showing their computer at work, which is a lot like that Minority Report experience.
Screen or to a separate device, a table in front of you, and in addition, collaboratively with somebody else in sort of a collaborative space. Both people have gloves. I'm not really sure what the efficacy is of taking letters and putting them on one side or the other, but the idea is that you could move something if it was value. Maybe in this company, letters are really important. Anyway, okay, so, sorry I'm jumping around a little bit, it's just, so, that's a good way to start. So Spencer starts talking about being able to utilize the phone or some device where there's other things other than, say, the touch screen or the keyboard or the mouse. In other words, that the device itself and its orientation makes a difference in how you interact with the software. So we're not utilizing just the screen input or whatever input, but the orientation of the device.
Nothing ever works in demonstrations. I don't know why.
Of course, he tried it once, it didn't work, so he's going to do it again.
All right, let me go back to my contacts. Select a specific contact. And then lift the phone to my ear. There we go. And now it calls my contact. I think it went in the wrong way the first time. So then it calls my contact. Let's see.
Now, why you didn't just use voice and then pull it up to...
Like that.
Okay, so we
Talk
now
to
know
them.
it works. And that's our own Rob Hilton on the other end of the line.
And then the other thing is, if we take this, let me pull up a picture here.
I'm sorry.
All right, this is of course the famous incident where my dad fell through the ceiling. I like to give him a hard time about that, and they've got this motion, so where if you touch the screen in two places, let's see if I can do this. You touch the screen in two places, then tilt, then it will zoom in to the picture and zoom out. And this is just, again, kind of version 1 of things that we're experimenting with in terms of interface, and smaller, and that's one thing that I wanted to show. I don't know if many of you are aware of that, but built into Windows 7 is a speech recognition software that works as good or better than any that I've seen. And so I just wanted to kind of demonstrate that a little bit. So to get there, if you open up Control Panel, and some of you might have messed around with this, but if we click Ease of Access, then built into Windows 7 is speech recognition. So I can say Start Speech Recognition. And this should start it. And so they have a sheet of instructions you can print out to start using speech recognition. And so to show I'm not cheating, I'll keep my hands up here and just work with the computer a little bit and see how this goes. I'm not great at this. I've just messed around with it a little bit, but I think it's really interesting how I can do most everything I want to through my voice. So I'll start, so I'll tell it, start listening. Start listening. This is a demonstration skill. Start listening. Close window. Open Microsoft Word.
Yeah, it does make the opening.
Talking is
make
much
any
easier
faster.
than typing, period. Don't you think? Question mark. Click Save.
It's just such a thing. Okay, now the interesting thing is that this is essentially multimodal, right? So you've got command, but you've also got data entry or text entry with the voice, and so that the program is able to distinguish between those. And coming out of the voice recognition world from the 90s, that's actually kind of difficult to do, because it has to understand context in some way. It has to be somewhat intelligent in what it does. And also, the way that Word is set up, it's basically just a generic recognition. It's not being trained in some way. Now, but the generic systems have gotten so much better, mostly because of the telephone system. So So for example, when we were putting things together for telephony, which is what they call it, you have a very limited list. And in the days of the mid-90s, basically you would have a list of only a few dozen things that it would even listen for, maybe even smaller than that. Nowadays it can actually recognize names. For a while they tricked us into thinking that it was recognizing names when we called 411, but in fact it wasn't. What they were doing was taking the recording of your voice and compressing it so that it was fast and taking all the white space out. So the operator actually heard it faster than you said it. And then there was a human at the end and figuring out where to connect you up to. But nowadays it will actually be able to do recognitions, even though there are many, many different voice types out there. Thousands of voice types that they have to worry about. But they've been able to accommodate that because of the processing speed essentially allows that. So Spencer, I'm just going to let Spencer say goodbye here, and then I'll get on to what I was going to do. Is it 25? And I apologize to Spencer
And it
now.
works a little bit better. So anyway,
Chopping
there's
off
just,
so much.
it'll be interesting to see as the devices change, as we start to switch more to tablets and to smartphones and to consume the internet that way, how the design that is considered good design today ends up, turning on its head and not becoming good design anymore. I've seen that a lot in terms of.
Although I wonder, he obviously has the Weber State page there. I'm wondering, is it like the 80s or the 60s? The stuff comes back, and eventually that's going to be, because people complaining about this all the time. It'll come back, right, Rob? I mean, I got to say, I kind of like being able to click up here and getting, all the things that are starting with the letter G. I think it's kind of handy.
Accessing, because I'm on the phone a lot, the smartphone, and I'm accessing websites and various tools, and in a lot of cases the design is not good. It's not good for the full website, and it's not good for mobile either, and it needs to get better, and I think it will. So anyway, hopefully that's helpful to kind of take a look at a few of those things. And the good news about doing this virtually is I don't have to be there to see the look of disappointment on your face about this presentation, so that's good, that's a plus. Anyway, hopefully that provides for some discussion points, and I'm sad I'm going to miss out on the discussion, but with that I'll go ahead and close, so Spencer out.
Okay. So I got Spencer's, I got this thing, and I said, I started thinking about what I was talking about, and themes started coming up, listening to what he said. And so what I did is I put together a presentation that basically kind of corresponds to a certain number of themes. I think I have 5, and then of course we can add our own as we go forward. So this is a Springfield rifle, a later version of it. The early version didn't look. This was the early version was early 19th century. I mean, late 19th century, early 20th century. Does anybody know the significance of the Springfield rifle? By any chance? So it's it basically was the first mass-produced weapon and device that had interchangeable parts. So before that, people had to make this stuff and craft it by hand. Now, subsequently, historians have gone back and looked and actually tried to build these things and realized that there was a lot of filing and burring and stuff going on. So it wasn't exactly, interchangeable parts. But that was the idea. And it worked fairly well. This is a Model T. Between the years of 1921, 1929, there was only one color you could buy the Model T in, and that was black. Before that, they actually had more colors available. The reason they went to black, so has anybody ever heard that saying, you can have any Ford you want as long as it's black, any color you want as long as it's black, I guess Henry Ford basically said, and that was true. But the reason he did this is because black dried the fastest. And so it was cheaper to produce a car with black paint because you could get it out the door easier, it would cost less, and he could basically sell that car to the middle class, which is what his goal was, that he should be able to sell the car to the same people that are making the car on the assembly line. Okay, on the left-hand side you'll see a web page which is out of date, although you can't see that it's out of date from here, other than maybe it's not fashionably crafted in some way. And then you see David Ferro Facebook page. So the reason I brought these two up is that when Facebook came up, basically what it did was it kind of mechanized the process of creating a personal page. I mean, if you go, you have limited options for certain things. You are either married or unmarried. You are single, or you are male or female. All right. Now this sounds obvious in some way, like doesn't that cover everybody? But in fact, it doesn't necessarily. And it also forces you into some sort of a paradigm of what you want to represent yourself as. Whereas in the page, when you created your own web page with HTML, you basically did whatever you wanted. There was a lot of ugly pages that were created, but the difference is in terms of the customization of what you could do and the more limited customization that you can do with a Facebook page. You pay for it. You pay for that with limited customization, but you gain access to 1 billion people and 637 million people that actually access the web page every day. So that's essentially a theme that that I'm working on, is this idea that individualization versus customization versus mass production. Now, I brought this up because when I was doing voice recognition again back in the 1990s, one of the systems that I worked on was called, it was for aphasic patients. And it was actually a trial of some kind, and there was a linguist who was in charge. And the idea was that they could relearn, if anybody knows what aphasia is, you basically lose your ability to, the subject objects get confused in your head. So you would ask a question on this computer program that we created, is the arm hitting the clown? Right? And they would get confused as to whether the clown is hitting the arm or the arm is hitting the clown. And a lot of them were violent like this, which is the reason I found this picture. I couldn't find some of the old pictures, unfortunately. But it was really kind of stuff that really was like stuck in your head, like a dog hitting a dog biting a man, or a clown hitting a dog, or so there's always like this really violent aspect to it. Anyway, the idea was that this program could basically take into account where people are and, in a sense, retrain their brains to understand language. And just as PowerPoint has retrained our brains so that we can no longer understand anything unless it's in a PowerPoint format, this technology is essentially affecting us in certain ways. So, okay, just wanted to show you one thing. And this goes along with the idea of what Rob had done before when he was talking about helping people that are not...
No objection was raised on the father's side.
Okay, this is called Dasher. It's the Dasher program. And when I was in Finland in 2007, I was over in, working with those folks, and this is one of the systems that they played with. The idea is that and Sherry knows this, they use the eye gaze. In other words, someone who has no mobility at all. Okay, so we talked about JR who had no sight. This person does have sight, but no motion ability at all with the body, and uses the eye to basically manipulate the computer. Small movements. And in this case is using the eye to fly through the letters. And what the program does is create the most likely next letter. So as you go through this, and I wish I could slow it down, because it's like the letters are just kind of flying at you, and this person's gotten really good at being able to get to the right letter. But you'll notice that he's flying through the letters, finding the right one as it comes up in these different colors showing, you know, the more obvious letter it most likely will be, and then it's being spelled out on the bottom. See it?
The young man was treated liberally.
Okay, so that was going to be his next question. Did you see the? Did you see it by the time you finally got through that? I could see father. I was like, oh, there was part of it. You want to see it again? Okay, there's Emily right there. Doesn't show, but he doesn't take it.
The young man was treated liberally.
Interesting, right? This is another way to do it. So again, finding some mechanism through the screen and the movement of the eyes to actually interact and get something out of the computer. It's not fast.
Somebody just wrote a whole book about 2 years ago using that. He became paralyzed. There's not a lot of attention.
Yeah, I heard about it on NPR.
I can't think who
It was actually on an iPhone, is what I think she meant.
Oh, I thought a person wrote it with their eyes. But yeah, I heard that one too.
20 years ago, Bannon et al. Observed that information workers often switch between concurrent tasks or activities. We observed that users of large monitors and multiple monitors leave substantially more windows open than do users of standard-sized monitors. Scalable fabric is a new visual metaphor for managing tasks and task switching, designed to take advantage of human spatial memory. A central focus area.
Okay, so this is the interesting thing about folks that are in the Chi. I mean, they're saying, okay, let's reimagine the metaphors already that are in existence, and they have to think in terms of, well, what's going to be intuitive enough that people will be able to figure out what to do with it, or there's another approach as well, which I'm going to get to in a couple seconds. So in this idea is that generally we find groupings of things that we're working, and they're coming together, and we want to open that whole group up. We want to bring up the whole thing and be able to work on individual components of that. So this is just a way to sort of keep that together. It's like having a series of web pages that you visited, and then putting it in a special bookmark path or a history path or something that you can then use. And then one more metaphor. Let's see if this works.
In this video, we present the vacuum, an interaction technique that utilizes hover to enable quick access to items on areas of a display that are either difficult or impossible to reach. The vacuum is represented as a circular widget with an inner bullseye center and an angle of influence controllable by the user, which extends to the limits of the display. Interactive proxies of all the objects in the extension of the angle are brought close to the user. The proxies are small-scale versions of the original objects, positioned in such a way that they can be reached with movements of identical direction, but smaller scale, as those used to reach the original objects. Selecting objects at close proximity to the user does not require the vacuum facilitator. Thus, they become...
Okay, so you've got this idea that there's a lot of stuff out there. Let's just suck it into one little location. So this is sort of the opposite direction. They'd already gathered things together. This is a way to gather things together and then be able to use them when necessarily. later on in a session with the computer. So, again, customization, mass production, one of the themes I'm going to approach, or we can approach. So let's go into a little bit of the history of how we got to this point, because these people are not just coming up with cool things. They're, you know, there's a lot of cognitive psychology that goes into it. There's a lot of engineering, and in fact, this idea of machine-human interaction coming out of a lot of what's called Fordism or Taylorism that happened in the early part of the 20th century was basically looking at this, and there was a name for it called cybernetics. Now, in the original part of computing, how we interact with computers were in fact mostly women, humans, who were interacting with machines, mostly some sort of calculator of some type. From there, we ended up with
$500,000. Markley and
women running
graduate student
computers.
Electrical engineering, Presper Eckert, set to work constructing ENIAC, the electronic numerical integrator and computer.
I just want you to be able to see the user interface. So there's the user interface right there. If you're looking closely, so I'll make that bigger. Basically, cables, switches.
Many times larger than Colossus, nothing close to ENIAC had ever been conceived.
And there is your output. Interestingly, ENIAC, so this is 1946 when the thing's finally working. It's right after the war. So it never actually contributed to the war effort, unfortunately. You know, it got a lot of money for it. It was not a binary system. It was, in fact, base 10, which for a computer scientist is really pretty curious. And this was essentially the output. So it's basically a giant calculator. They would put in trajectory tables was the big thing, because trajectories were really hard to calculate. And it would come out, you know, the answers would come out there, and somebody would basically go along and
100 feet long
record
and
them
weighing
in some
30
way.
tons. It contained almost 70,000 resistors, 10,000 capacitors, 6,000 switches, and 18,000 delicate vacuum tubes. Vacuum tubes burn out just like light bulbs. In a machine that contained 18,000 vacuum tubes, at least one had to be replaced every few minutes.
Okay.
Wow.
After 2 years
Okay, so there's the other part of the user interface right there.
of
Every 2
intense work,
minutes.
Can you
the
believe
team
that?
completed
How
ENIAC
did they get anything done?
3 months after the Japanese surrender.
They had a lot of redundancy built into the system, so a vacuum tube could blow out and there'd be like a backup vacuum tube. So somebody would be swapping the vacuum tubes. The thing would be running at the same time, and people did get electrocuted. So, a little more dangerous than using your iPhone today.
Unless you get hit by a car.
Yes.
These guys went on to create the UNIVAC, which is where Unisys came from originally. Sperry UNIVAC, and the UNIVAC was used, had a keyboard. It had punch cards, which came out of IBM from the early part of the, actually came out of the person who created the system for the census in the late part of the 19th century, Herman Hollerith. And they took those cards, he got the idea actually from railroad cards, like they would punch the holes in them. He said, oh, those identified somebody in a car. He says, oh, we could use that to identify the people that are in the country, and so they created this huge system. That was later bought up by IBM. That was basically a tallying system, and those systems eventually found their way merged into what we have as computers. And for those of us who are old enough, remember punched cards. They lasted a long, long time, and were the primary way of basically inputting information into computers for a long, long time. So even with keyboards, punch cards kept around for a while. So what happened was, after that, suddenly the Apple computer was made. Well, no, but this is what we essentially look at as our basic interface to a computer still today. So 1984, this comes out. It doesn't have anything but a floppy drive in it. It has no software that anybody really cares about until they create desktop publishing later on, and then suddenly it's actually something that can do something. Before that, it's kind of cute. It has a single click mouse, which we all still know today, and a keyboard. Now, where this came from was Steve Jobs went to Xerox PARC. Xerox PARC had created the Alto system. The Alto system came from something from Stanford Research Institute by a guy named Doug Engelbart, this guy here. Doug Engelbart created the mouse, and there it is in its original wooden format, and it has a button on it. You'll notice he's holding a newer mouse, I think it's from a Sun system, that's got 3 buttons on it. And Doug's idea was that the one button wouldn't have made sense to him, because to him, he came out of the world of cybernetics. In other words, the human and the machine merge in a way, both learning about each other to create a more effective and efficient way to do the work. So in 1966, what's called by many people the mother of all demos was done. And I just wanted to show you a little bit of that. And we'll skip ahead because there's a lot of... This is the mother of all demos in many ways, actually, because he used a lot of technology to show how it works.
And I'm going to come to you mostly through. I hope you'll go along with this rather unusual setting and the fact that I remain seated when I get introduced, and the fact that I'm going to come to you mostly through this medium here for the rest of the show. And I should tell you that I'm backed up by quite a staff of people between here and Menlo Park, where Stanford Research is located, some 30 miles south of here. And if every one of us does our job well, it'll all go very interesting. The research program that I'm going to describe to you is quickly characterizable by saying, if in your office, you as an intellectual worker were supplied with a computer display, backed up by a computer that was alive for you all day and was instantly responsive, instantly responsive to every action you had, how much value could you derive from that? Well, this basically characterizes what we've been pursuing for many years in what we call the Augmented Human Intellect Research Center at Stanford Research Institute. Now, the whole session is going to be devoted to trying to describe and present to you the nature of this program. But unfortunately, the products of this program, the technology of it, lends itself well to an interesting way to portray it for you. So we're going to try our best to show you rather than tell you about it. And I say, well, this is going to be more important than it looks.
Sorry,
I'd like to put up a file. So I told the machine, all right, I'll put to a file. And it says, well, I need a name. I'll give it a name. I'll say a sample file. And I'll say, geez, I'll put it into the fifth.
Okay, so not all, everything was connected with this idea of utilizing the computer. I mean, he's in a special chair. He's got this special desk thing. This chair is like swiveling around. It has special ergonomic properties to it. They actually experimented with the idea that the knee would manipulate the mouse originally. And the knee was amazingly effective at manipulating a mouse. It's amazing we never did anything with that for people that say didn't have arms or whatever. But you'll look here and see that there's a keyboard built right in. On the right-hand side is the 3-button mouse. I'm sorry it is so blurry. This is just the way it is right now. And on the left-hand side, it's what's called a chord keyboard. Does anybody know what a chord keyboard is? So basically, 1, 2, 3, 4, 5, 2 to the 5th, that's 32 unique possibilities with your 5 fingers. In other words, you can type every letter of the alphabet with just using your 5 fingers with one hand. And the original idea was that you would know the binary codes for all the different letters.
That's cool.
And in fact, this would go away. You didn't need the keyboard. But of course you have to know the binary codes in order to make it work. And Doug used to practice them on his dashboard as he drove in every day to the Stanford Research Institute. You would have maybe 2 of those things, and maybe use your knee a little bit, and you'd end up being able to manipulate the computer in a unique way. But you had to understand it. You had to have practiced it and become good at utilizing the technology. Totally the opposite than what happened with what the mouse ended up as, which was basically one button, and the child of 4 could do it. So it's a completely different way of looking at how using user interfaces should in fact be either somehow natively intuitive or not, but maybe more effective in the long run. Just like all of us who grew up with WordPerfect 5.1 knew all the keystrokes that we needed to use with the function keys and got what we needed. So that's the basic idea. And that gets us to, there's the key, chord key set right there. So 5 keys. And that gets us to another theme, which we'll see in a second. This is Vannevar Bush. Why did Engelbart create the mouse? Because he had read an Atlantic Monthly magazine article called As We May Think. And it was by this guy, who was an MIT scientist who helped with the war effort. And he's standing in front of one of his differential analyzers. This is an analog mechanical device that calculates trajectories for war effort. And he basically came up with this idea of something called a Memex machine. Now remember, this is, again, coming from the ergonomic approach. In other words, man-machine merging in some way. This idea of cybernetics. And one of the war was probably the time when a lot of this stuff really hit home. In other words, some of the work that we did to try to create the most, the man-machine combination with this machine gun ball that sits under a B-17. Which must be an exciting ride, I'm guessing. But this gets us to our second theme, initial ease of use versus learned human augmentation, or something along those lines. Okay? Let me just show you one thing before we move on. Doesn't want to work. Just give me 2 seconds here. Huh. Okay, not compatible. All right, so I can show it to you sometime. There's basically how the Memex works, and I can explain it. So the way the Memex works is, and he was thinking about it in terms of like tapes, but he invented the idea of the links, the browsing links and history and page marks and saving those pages. I mean, this idea that you would go through a system and so he gives this example of trying to go find information about the Turkish bow, and you create this pathway through articles, which then you can look up again 3 years later because you got into a conversation with somebody about bows and Turkish bows, and it's like, oh, I got this Turkish bow sequence that I found and all this information. And of course, he's thinking about it in terms of the technology at the time, so it's like a desk with some screens that basically show microfiche kind of thing, and you can calculate, or use this entry system to get it. But But again, it was the concept that was there. And that's what Engelbart was thinking about, was this augmented intelligence idea. That's where the idea came from for the mouse. All right. Okay, one more sequence, and then we're going to stop because we're getting close to 30.
Welcome to the Caribbean. I'm waiting for you.
Pay attention.
Go ahead.
Create a red oil tanker.
Where?
There. Put a blue cruise ship.
Where?
East of the Bahamas. Make a yellow sailboat.
Where?
North of that. Create a green freighter.
Where?
East of the sailboat.
Okay, so you're going to go home tonight and it's stuck in your head. It's going to be where? The idea is some sort of sentience here, right? You are being able to tell it generic things, and it's able to figure out where to place it. North of here. So you point to something, and it's not only able to understand what here means, but it's able to understand what north of here means. And that, this is this is pretty old, but that's the kind of thing that where, like imagine you're working with your phone and the maps on there, and you're able to talk to it in a way, in a relative way. It's like, I want to go, 2 miles east of here, or something along those lines, right? This idea that you're able to, then the computer is able to actually figure out from where you are and from what you would say relevant to that you would get it. Now, compare that to okay, so our basic keyboard entry. And he's doing keyboard entry, but then
you shouldn't have come back.
So there's a computer in there that's actually able speaking. No, it types it too, but it's speaking to him now. And
hey, it's the big master control program everybody's been talking about.
And it responds to him speaking too. So this is a great combination of ways of entering information into the computer.
That is Tron, right?
That is Tron. So sentient object versus human extension. That's my next theme, essentially. And I'm going to have to stop there because we're going to run out of time, but I'll continue it on in the next one. So given those 3 questions, or 3 themes already, and thinking about Tron and the different ways that he's utilizing the system, maybe it makes sense for someone to think in terms of building a system where there's different ways to enter information. There's a reason to do those things. Maybe typing a password in makes more sense than speaking it out loud, right? Now, Tron, of course, then vaporizes them and has the ultimate user interface experience. It's actually in the computer playing Frisbee or something. Did anybody see the latest version of this? Tron, yeah, so. It was a good time. So, anyway, let me stop there and we'll continue on, at least with this show later. But let's open it up, if we may, to more discussion. Is any of this stuff relevant to building web pages?
How could it not be? I mean, I guess the user experience in a web page is everything, isn't it? And so if you're finding more ways to be interactive with the web page itself, you're going to increase the value of the web page, aren't you?
And kind of along the lines of what you've been talking about, I see two types of inertia here. You have the inertia where the technology develops in a certain way based on what has preceded it, and then you kind of have the cultural inertia. People get used to interfacing with the technology in a certain way, and so that promotes itself. Maybe physiology and the technology lends itself to different pathways, but because there's a cultural know-how, it's really hard to get away from that inertia. And then also in terms of the technology inertia, it's hard to get away from that because that's the way it's been done in the past.
Yeah. Can we talk about that a little bit also? Rob's brought that up, the idea that, well, you've got this huge, cohort that knows how to use the technology in a particular way. And we did talk about, are we getting better, or are we just putting up with, user interfaces being so different in many cases now, for whatever reason. There's so many different apps written by so many different people, or there's the fact Facebook changes every week, whatever. Yeah, you're right. There's the inertia is an issue. Although maybe that's talking about it pejoratively. Maybe there's some value to it in some way.
Well, there's some efficiency. You have to learn something. You lose some efficiency in learning a new system, even if it optimizes certain things. You lost time in order to learn something new.
But you bring up an important point, Patrick. What moves things forward? Is it technology or is it culture? Is it because everybody likes an interface that it takes hold, or is it because there's a backer to that technology that moves it forward? Because when you were talking just now, I'm thinking about the one company that kind of merges both of those. That's Apple. Apple sets a cultural context for their technology and effectively doesn't try to ram it through, but does in a sense, so that you've got those two pushes on that technology to move it forward. And by moving it forward, again, I'm just assuming that we're progressing, in our user interface and our user space. That's actually a really interesting question, because from an entrepreneur's perspective, or a startup company perspective, the thing that you're constantly trying to do is validate your product with the user. And the ultimate validation is if someone will buy your product. So usually what we're trying to push and what we're trying to figure out is if what we've created solves a problem for the customer. So from an entrepreneur perspective, like you said, is it the culture or is it the user, right? And so when you look at it from an entrepreneur business perspective, they're always saying it's the user that dictates it, because if the user will buy it, then we solve the problem, we'll pay money for it. But I mean, Apple is one of those unique things where they kind of went against the grain of how you would actually create a product for someone to buy it.
And part of that, I think, is the cachet associated with Apple. I mean, there really is, it comes back, you have to excuse me, kind of coming from a patent attorney / trademark attorney, but you really have, people are very brand sensitive, and so if you have something that has kind of portrayed itself successfully as being cutting edge, I think people are more willing to buy into it, just because of the cachet associated with the logo, quite frankly.
But even still, Apple solves a problem.
It does.
I mean, MP3 is a perfect example of something that was out there for a long, long time before Apple got a hold of it. It said, the reason why this isn't working is because it's not put into a design a way that is intuitive to people, and Apple capitalized on solving that problem. So, I don't know. I mean, to me, my instinct is always to say that user interfaces are going to always be dictated by the user themselves, because it's going to solve something for them. If you're not solving something for them, then why? Yeah, I know. But implied in all of these Steve Jobs demos and Apple demos is always the one-button mouse. You will like it.
Yeah.
The iPad. You will. I don't love this. I mean, this is just how you wanted it. And so they set that stage.
There's a really interesting example with this, with Swipe. iPhone, do we have any Androids in the room? Okay, if you use Swipe, and I work a lot in mobile, you present somebody with Swipe and you present somebody with not Swipe, and the consumer will choose swipe. Swipe is one of the coolest keyboard things going. And have we all seen what swipe is? On data entry, on phone? Like just when you do keyboard entry, let's see if I can just show you quick.
Is it built into the OS?
Yeah, it just comes with Androids. And Apple doesn't do it. And there must be a reason that I don't know, because but if you look at the way you do character entry on the iPhone, you tap letters out. And on Swipe, you just draw the letter. And so you just with your hand write stuff, and it'll present you with some choices. But when you get used to swiping, and I go back and forth a lot between iPhone and Android, and I've seen a number of people in the last 6 months in particular give up their iPhone, which is heavily branded, and they were invested in iPhone, but their buddy next to them is texting the Swipe, and they just, I have to have that, so they go to the Apple store and say, I need Swipe on my iPhone, and they say, no, it doesn't exist, plus you don't need it. And then they go back and they're still, and I've seen people tip considerably to Android, and if you watch the numbers, Android's doing this and that, and it's funny, but the Swipe itself is a tipping factor for a lot of people.
Don't take your finger.
But that is solving the problem, right? It's the interface.
Yeah, so
it's solving that.
They presented 2 choices to the user, and the user said, yeah, for the problem of texting, this is way better. And so even though they're heavily invested in Apple, they're willing to switch to an Android to get that interface.
That's interesting.
Although I think it depends, because there's plenty of teenagers who do this, and Apple allows you to even split the screen so that they can thumb it.
So is Android. You can
Yeah.
do keyboard with the thumb.
But not all consumers want this way.
No,
I think
that's right.
it depends on who they are.
But
and
it's
how
just
they're
been
doing it.
interesting to me to watch people switch on that one feature.
Well, and I think,
And a number of
and I think Samsung actually is more sensitive to, I think in some ways Apple has able to dictate to people what they want, as opposed to, I think Samsung's approach has been to say, oh, let's do psychology, let's look into the physiology, what actually works well for people. And I mean, that's part of the reason why the Galaxy, the new Android phone, Samsung phone is actually larger. And that's largely a response to input that they've gotten from the consumer. And so Apple's interesting because they do dictate more to the consumer than most successful companies. And I think a lot of it has to do with the mystique of Steve Jobs. He's kind of become an icon in terms of innovation. And part of it is also because he has been able to successfully anticipate people's needs before they realize that they needed it. But I think Samsung's approach has been to say, oh, as a consumer, what do you want? And so it's an interesting paradigm.
And along those lines, too, I had an interesting conversation years ago with one of the iOmega founders, and if you're, I guess everybody here's old enough, my students aren't to remember zip drives, but,
Oh, it's gone now, they don't remember
no,
anymore.
I'll say something about a zip drive in there. Is that those, no, that's a floppy disk, this was different. But I had a really interesting conversation because iOmega was struggling, and they needed to come out with a new product. They had their first early drive, and they decided that instead of their approach up to that point, he told me, had been to build a good product and then talk people into buying it. And he said, we decided with the Zip instead to find out what people wanted to buy and then build it. And so they went in and they talked, and I don't know if you remember the Zip, for instance. One of the funny things, the reason it was the color it was and everything, but do you remember the zip drive didn't go all the way in? You know, your floppy would go chunk and it'd be gone. In their study, they found out that people got nervous with their stuff going away, so they let it hang out a little bit, specifically so that would make people relax.
Because you used to put in cassette tapes, they used to do the same thing, and all of a sudden instead of eating it because your cassette tape, like, well, what? You can't get it out. I don't know if that was the.
So sometimes you couldn't get it.
It was just eating it, like, that's my 404 tape.
And a lot of that was market research done by an ad agency in Salt Lake City, and my husband did the ad campaign.
And everything about the Zip was carefully calculated to meet a consumer need. In fact, I don't know if you remember the campaign that they did was your stuff. They didn't call it data, they didn't call it anything else, it was your stuff, and that was also calculated. And I think that the winner in the interface world will be the person that finds out how people want to interface with the
But the interesting thing to me is that Apple has been so successful, and it actually started from the very beginning. I mean, Steve Wozniak, when he made that first board, I mean, it's a beautiful board, and it's just one guy. He didn't do any market research. He created this computer, and it's almost like the auteur representing this huge percentage of the population that was hungering for this thing. And you kind of have to put up with the idiosyncrasies of that vision, but you get a lot of something that you didn't necessarily know that you were looking for in some way. And then suddenly people are doing research and realizing, well, actually there's better ways to do a lot of this stuff, and coming up with the swipe, for example.
Well, I think it's a little bit like, if you want to take it further metaphor, kind of off the auteur, but really, what makes something excellent fiction, what makes something excellent in terms of arts, and it's really tapping into a certain audience. And sometimes it's calculated, but sometimes it's just creative genius. And I think the easiest way to go about it when you're not brilliant like me is you do a lot of research and you say, what is it that people want? But I think there are people who really do have that kind of creative genius that almost anticipate in advance what people really want. And those are the products and also the media that is successful later on, because they have that genius to tap into kind of this greater conscious, if you will, of what people want.
Well, and it's also being able to go beyond what people say they want or what they think they want to what actually solves something they wouldn't even have thought of necessarily. And so there's a lot of things that are happening in that realm as well, where you just observe and watch and test and then see how you can go beyond what people actually think.
Yeah.
But
I keep thinking of that Simpsons episode where he makes a car, like his brother's car.
Oh, yeah, the most expensive
most expensive, ugliest looking car in the world, So,
I do remember
the very opposite of the artistic auteur.
But then he comes back and makes a tool that reads babies' thoughts. That was later, which was useful. People wanted it. And he could sell it.
With the 6-month-old, it would be useful to have that tool. That brings up the sentient object thing, because it's something that interests me. Is a computer that can think going to be useful? And is it everything that people want? I mean, are people just generally drawn to it because that's what happens in the movies? But if you think about it, I would just hypothetically say that there's a good portion of the public that would not want a thinking computer. I think it scares them. And for us to just kind of go in that direction because we think it's the next step, might not be a good user interface decision in the end. I mean, it might be a neat novelty.
That's where you get to that uncanny valley, when it's too close to human but not.
Right.
It becomes really creepy.
And even the popular culture is, it's to be very careful with the computers that can think. Because you think of Vicky and iRobot. But, so, this being able to talk to it and have it talk to you about it, or rap with it, like he was in Tron. I don't know if a lot of people want that. I mean, I think a lot of people just want a machine that does what it's supposed to, and not necessarily think for them in a cognitive way that we do, or similar. I think that, because what problem do you really solve? I mean, what problem does it solve? I think it causes more problems. I mean, yeah, does it cause more problems? And if it's not really solving a problem, then, I mean, yes, it's cool to interact with it. I mean, here's a common university problem, is coming up with solutions looking for problems, right? And I think that happens a lot. You have this great solution, but it doesn't really solve a problem. And I think that's maybe what you're talking to, is like, yes, it does something, but what is it really solving, except that it talks back to me.
So, tomorrow there's going to be a panel discussion called, the theme, the question is, if a computer could do everything an instructor could do, should it? And, that's sort of another way of posing your question, if the computer can start to think, do you really want it to? So it'll be interesting to see people's answers to that tomorrow. I guess it's partly, part of the answer is it something, is the activity that you're asking the computer to do, is it an instrumental activity that we're doing for some other, to pursue some other end? or is it something that's intrinsic and that we value in and of itself? So if it's an intrinsic activity, if it's something that, if it's duplicating human activity that we want to be doing ourselves, then no, we don't maybe want humans to do, I mean computers to do it. I don't know. It's just
Right. That's an interesting point.
You start to outsource things, and then we're all the people from Wall-E in
Right.
our chairs and not doing anything anymore.
I look at a little bit how Google's evolved as a search engine too, and how, you know, we say, oh, I don't want the computer doing the thinking for me, but then you have a little, you know, smile and a warm glow because Google got what you meant to type in and understood exactly what you were thinking because you had a basic idea of what you were trying to pull from the net, and you had a couple of keywords that were close enough, and there it happens to be the third link down, or, you know, third link down and your spelling's been corrected for you. And, you know, when you're talking about the instrumentality of it, I think that the rising generation is getting very comfortable with a sentient computer working for them.
Yes, I did user testing this summer with college students, asking them how could Google be better. Almost all of them said if it could read my mind and just give me exactly what I want instantly without me having to mess with it. Which to me, I love to research, and part of the hunt is why it's exciting and interesting, because you find things you didn't expect sometimes, and for them to say that was actually really surprising, that that's what they would want.
You know, we see the TED Talk, the filter bubble, in which
Yep, I read that book. It was excellent.
I'm just wondering why that you focus group didn't have a chance to see the TED Talk.
No. If I was doing user testing a little bit more cold, one-on-one. So they didn't say it in one room together, agreeing with each other singularly without being led. They said that that's what they wanted.
We have to qualify it, right? I want Google to read my mind for the purposes of searching.
Well, and that's where it goes, yeah.
So, I want Google to read my mind.
All the time.
You're asking for trouble, you know, I think.
Yeah, and I think it
Here,
posed
you want to buy
that
this
way.
product and that product? No.
Right. I think the students would agree that, oh no, that's going too far, but yeah, where do you draw that line?
Yeah, and the pushback to some of the AI behind the TV programming, the first generation of the DVR type services, where it was making recommendations that people were uncomfortable with, even though it was spot on with their viewing habits.
They didn't want to be told that that's what they
didn't want to know that, you know, the burly guy was into romantic comedies or whatever, you know, so awakening that it wasn't ready for.
That's a fair point. If it starts to reach some of those thoughts, like, whoa, yeah, I don't want people knowing that that's what I want. Yeah.
Well, Netflix had problems with that too, those recommendations being a little too on the nose.
But when they make wrong recommendations too, that's a jolt to this. I mean, it's a jolt to the psyche. It's almost like, you know, that annoying brother or sister who's just jumping on everything you say and saying, oh, well, you like this. I mean, watch this thing instead. And to me, that type of interaction is not what I want from my machine. I want to stick in line with, you know, with the goal. So I know what they're going for.
Well, it's interesting because it's a slight tangent, which is like target and data collection, right? So Target supposedly, they get enough data, they can tell, like you can buy certain kinds of items and they can tell certain things. And the famous story of Target is a girl came in and bought cotton,
it was really
random things, and the output was, your daughter's pregnant. And so it sent so all of a sudden it started to target her, well, those pregnancy things, and the dad got really angry. It turns out she really was pregnant. So like it all of a sudden it cans this idea that teaming this up with a user interface with data collection, data information. It's not the Netflix problem, because that's what Netflix does. They're teaming all this data they collect, putting it into your interface that's telling you what, and that's
so
powerful. And so is
Yeah.
Google, but that's
In fact, actually, you guys may have heard about when Yahoo released people's data searches, and they actually just did it by numbers, and a reporter was actually able to deduce from the data search one of the people, you know, was able to identify the person. And so it's just, really is amazing the information that's gathered on us, and then what the capability of that. And that is to some extent why Google is so intuitive, is because there is so much, you know, data mining.
But see, to me, this goes back to when we start talking about user interfaces and all that kind of stuff. You have to wrap in data, and you're probably going to have to wrap in privacy controls and how all that's, because that's all, I think it's all going to be part of the interface experience is, well, how do I know that what I'm